people are
You
actually
like
good.
outrun like
You can still
second
run.
baseman.
I know, but people are actually good, so.
He's just saying it's like hard.
Like in other
Hey,
areas.
you can't steal home in high school baseball.
Yeah, you can.
No.
You could. If the ball passes, I can.
Yeah, well, a pass ball, but not just a straight.
I know.
Or am I gonna need this angles?
Like in El Dorado ball, you can
Angles
just
thing.
steal off any pitch you want, because you
At
catch
least
the
in
ball.
that's how I'm
Do
doing
a second
it.
baseman threw it to home, and like Billy ran with the throw.
I know,
And outrun the throw, and he's like, "Alright, come on, I've already slid."
He tagged up and ran home.
Oh yeah,
I
and
need
he
to
throw
check it
out.
out.
He is speed because they don't think he's actually gonna run for it. He's like, "Sound like better."
All right, today is the 10th. This is the
Is that all?
right triangle review. Listen, right triangle review. Might skip a space between each one of these. This is what your test is going to cover. Some of it's been a long, long time ago since we had long break in between there and all that stuff. So I highly suggest you skip some space and write all the stuff down to maybe refresh your memory. The packet that we do, the review packet, hopefully that'll help some. Maybe next week, since you have a little extended time in between your test or the review and your test, if you wanted to come in during intervention, get some help, might be a good idea. Just to refresh your memory, especially stuff like the geometric means and the altitude to hypotenuse theorems. With Pythagorean theorem, I wrote triples in there. You might also write families. We'll get to that and put some extra stuff with it. I believe on this test I will allow you to use these notes that you're writing down right now. So probably that one whole page, whatever it is. So everything you write on there, anything that's going to help you, might be a good idea.
See that on the board? I'm like,
All right, geometric mean. With the geometric mean, you have to set up a proportion, and that proportion is always going to be something like this. The first number that they give you goes there. The second number they give you goes there. Those are your extremes. And then the geometric mean has to be in both of these spots. So the geo mean goes there, geometric mean goes there. Don't let geometric mean, that was one of the easy things that we did this chapter. So just because it's been so long ago, don't let it, mess you up. If you're finding the geometric mean, all you got to do, they give you two numbers. Maybe they say like 2 and 6. All right? And all you do is set up a proportion. 2 goes here, 6 goes there. What do I put in both these spots? And then you solve. X times x is x squared equals 12. And then what do you do to get x by itself? Take the square root. You end up with x equals, and remember the geometric mean, there should be two answers to this because you're going to have a positive and a negative answer. But the geometric mean said it only wanted the positive one. So all you got to worry about is the positive one. You could take your calculator and solve that, whatever the 12 or square root of 12 is.
2 times the square root of 3.
All right. Or you could break it down. Remember when we were breaking stuff down, and since there are multiple choice questions on the test, they may give your answer broke down. You take that list, you might want to jot that list of perfect square numbers down there if that's helpful to you. A lot of you might not need it. You find a perfect square number that'll divide into 12, which is 4. To break it apart, what is the square root of 4?
2.
So the answer would be 2 times the square root of 3. So Brighton, your calculator does that for you, right?
Yeah.
Have you had any trouble with it as far as the sine, cosine, tangent? Is that
I don't even have to press second, but just press like sin twice and it just goes to
what it is?
A lazy calculator, that's what it is.
my fraction button isn't an ABC button. I hit a number, hit fraction, then it automatically puts it like in a picture of the number line, and then automatically goes to the second one. And I'm like,
So see, that's like a computer, that's what I have to do on the computer. So that's a geometric mean. Anybody confused about those? Everybody sort of remember that?
yeah.
All right. Do a few problems with that. It'll help you study. The altitude to hypotenuse theorems. We had two theorems. One dealt with the altitude, one dealt with the leg. I'm going to draw a picture, then I'm going to erase this. So remember, altitude to hypotenuse, first thing you got to start with is a right triangle. And then you're going to have another segment coming up through here that goes over to that hypotenuse. That's the hypotenuse. Goes over to that hypotenuse and forms a right angle. Altitude to hypotenuse. So anytime you have that picture, this is your altitude. Then you have a leg here, and then your hypotenuse over here. We had two different theorems that dealt with that, and I'm going to do the proportions to those here in a second. I wanted to draw the picture first, but I just don't have room up here to do it all at once. All right, the altitude theorem. The proportion for the altitude theorem, what's going to go as the geometric mean? Altitude. So altitude goes here, length of the altitude goes there. If you don't know the length of the altitude, then you put your variable in there, x, y, whatever it is.
Wait, what?
So if we go back to this picture, this is our altitude. Whatever that length is, we put it in both those spots. You're always just setting up a proportion. See if I remember what goes on top over here.
The leg of the altitude.
Hypotenuse part
Yeah.
1. Remember, when the altitude goes over to that hypotenuse, it splits it up into two parts. We call one of them part 1, one of them part 2.
Does it matter which one's which?
Not really. Not for this one, it makes no difference. What goes down here?
The other one.
The other one. Hypotenuse
Part 2.
part 2. So you set up that proportion. How many of these should you know numbers for in this proportion?
All of them.
All of them?
2.
At least 2. 1, 3.
3, and then you solve for the other one, right? So you're going to know, like maybe they tell you that this is 4, this whole hypotenuse is
16.
16. So we'll know this. We know this. What is the second part? 12. Now I sort of lied to you because we only know 2 of them there, but what do you know about the altitude? It's just going to be your x or something, so you put x here and x there. If they tell you the altitude, then you put that number here and here, and you'd have to know one of the parts so that you could find the other part. But it's using that proportion over and over. If you're looking for the altitude or dealing with the altitude, then that's the proportion you're using. The leg theorem. Leg theorem, same picture. Altitude drawn to a hypotenuse of a right triangle. But this time the proportion, instead of being altitude as the geometric mean, what goes in these two spots? Leg you're trying to find. And remember, it's the same leg, not the 2 different legs. It's got to be the same leg. See if I remember what goes up here. It's the hypotenuse part, but it's not the part like part 1 and part 2, it's the part
To the leg.
that's connected to the leg or hooked to the leg. The part that's hooked to that certain leg. So if I'm dealing with this leg, which of those two parts do I want?
One.
Number 1. That's the part that's hooked to it. That's what goes up there. What goes down here?
B. The part that's not.
Full hypothesis.
The whole hypotenuse. So don't get that confused. For that certain theorem, it's when you're dealing with the legs, or one of the legs, it's the hypotenuse part that's hooked to that certain leg, over a leg, then that same leg over the whole hypotenuse. So you got to be careful with that, because if they tell you something like, let's say they tell you this side is 1 unit long and this part over here is 2. Well, what has to go down here? 3, because that would be the whole thing. All right, that's not the way when I do the 1 and 2 there. That's not what I meant them to be. But so using that theorem, those two theorems, all you're doing. I know it seems hard because we don't have a picture with anything in it, but they're going to give you a picture. And they're going to give you some information. Maybe they tell you something like this side over here is 7, and maybe this part is 2, and they want you to find the length of the whole hypotenuse. Well, how would I set up that proportion?
7.
2 over 7
Oh, yeah.
equals 7 over x.
And then you just solve that proportion, and that would tell you the length of the whole hypotenuse. What if you found that hypotenuse, you figured out what that number was right there? How could you go back and find this third side?
You label it as Y.
Could you do that and label it as y?
Yeah.
Yeah, you could. Is there an easier way? You could use Pythagorean's theorem, and that's what we're going to cover next. You could just use Pythagorean's theorem. Once you know 2 of the sides of a right triangle, you can use it, or find the third. So you might want to write that in here. If you know 2 sides, you can always use Pythagorean's theorem, and that's something that you guys have been doing for a couple years, so that might be the easiest way to find the third side. If you know 2 sides, you can use maybe one of these, or sine, cosine, tangent, or 30, 60, 90, or 45, 45, 90, but Pythagorean's theorem, since you have known how to do it for a couple years, might be the easiest way. Remember, Pythagorean's theorem is a squared
Plus 3 squared.
equals,
B squared.
A and B are the what?
Legs.
Legs, and C is the
Hypotenuse.
hypotenuse. Good. Let's write out the triples. Let's do the families real quick. Anybody remember any of the families?
3, 4 over 5.
3, 4, 5, that's one family.
I don't remember.
That's
30,
the
60, 90. Or no, was it 3, 6, 9?
Yeah.
5, 12, 13.
5, 12, 13, 8, 15, 17, 7, 24.
25.
There's actually one other one. There's one other one that every now and then you'll see. Somebody do me a favor and on your calculator, let's take 40 squared plus 7 squared. Keep that number. All right, just 40 squared plus 7 squared. Everybody keep, or some of you keep that number. Somebody else help me out and do 41 squared.
16.
What'd you get?
1,681.
1,681. What'd the other one come up as?
1,700.
So they're not the same. Which one is it? See, I can't remember the other. It's not one that gets used very often, so we won't worry about it. Those are the 4. Remember, with that, if I give you a triangle, and I tell you, let's see if I can make up a difficult one. This side's 24, this side's 45. could you use Pythagorean theorem to find that missing side?
Yeah.
Yeah. And if you don't, if you can't figure out that it fits a family, you don't see that it fits family, go right ahead. You don't have to use the families, it just makes it easier. Can anybody see which family it fits? 8, 15, 17. What I do to each number? So what I do to that 17 to get this side? Alright, so if you can see that it fits one of those families, then you don't have to go through the whole headache of plugging in here and doing all that. But if the families don't make any sense to you, then just don't worry about them. Alright, 30, 60, 90 triangle. In the 30, 60, 90 triangle, I'm going to draw each one of these just to make sure you remember how to label them. Side across from the 30-degree angle is always going to be labeled what?
L.
Side across from the 60-degree angle.
L times the square root of 3.
Side across from the right angle.
2 times L.
All three of these last three things, make sure you label the triangle. Okay, quit working, being down there too far. Label the triangle first. Very first thing, go through and label it. L radical 3, 2L. About a 45, 45, 90 triangle. Sides across from the 45-degree angle should be labeled what?
L.
Both of them are the same. Side across from the right angle.
L times the square root of 2.
The way I remember which one's radical 2 and which one's radical 3,
Wait,
30,
different
60,
angles you want to tell us or not?
30, 60, 90. 30 starts with 3, radical 3. So I just say, all right, all these,
No, I can't.
this one deals with 3s, that one deals with the other one. And it's two sides that are the same, what if you wanted to remember something like that, but I usually remember the 30, 60, 90, then that helps me to know, hey, the other one's gotta be the square root of 2. With the 30, 60, 90, let's go back to it real quick. With the 30, 60, 90, remember they might have an equilateral triangle. If you have an equilateral triangle,
Also equiangular.
what do I know about this angle? 60, this angle? And if I draw in, what's this thing called right here?
Yeah, I'll
If I draw in altitude, what kind of triangles are formed?
right triangles.
30, 60, 90 right triangles. Alright, so if you have an equilateral triangle, you draw it in altitude, you're also going to have two 30, 60, 90 triangles. What could I write here with 45, 45, 90 that we did? A square. If you have a square, and you draw in that's not much of a square. If you have a square and you draw in a diagonal, what kind of triangles are formed? 45, 45, 90. So remember that because I know there's some problems on the test about that. So equilateral triangle goes along with 30, 60, 90. Squares, different kind of problems with 45, 45, 90. And then the last one, the trig ratios. Key thing with the trig ratios. What's the S stand for?
Sine,
C.
cosine, tangent.
Sine is what over what? Opposite over hypotenuse. Cosine is,
Adjacent over hypotenuse.
and tangent is.
Opposite over adjacent.
Alright, key thing there, remember that, know how to set up your equations and your proportions. The other thing, if you're trying to find an angle, what's the first thing you're going to hit on your calculator?
Second and whatever the
If your calculator is one of the
cool ones.
ones that prints across the screen, that's the only time you're going to hit second and use that. Be able to do all those real world problems, so be able to draw the pictures. Brian, I will take off points on your test if you waste time and draw me some great pretty picture on there instead of
So you want
putting,
us to try?
putting the.
So you want bad art?
I don't care if you draw a picture, but I don't want you to sit there for a half hour like that. I don't want you to sit there for a half hour drawing pictures and then only get 3 problems done on the test.
No, but I draw such good school
I love your artistry, Brian. I'm not saying I don't like it. I don't want you to waste that time when you should be.
with the chair
I don't want you to waste that time when you should be putting it into making sure that you do well on the test. All right?
Are you saying you do or don't want us to?
I want you to draw the pictures,
But don't draw extra stuff.
but
like
I don't.
Sea Lodge.
I don't want you to draw.
Wait, we do have to draw pictures? I always just do it.
Yeah, if you do it, that's fine. That is a picture. Alright.
I have to get a
So
5%.
so if you go to Mrs. A, she's probably gonna say, well, that's not much of a picture. But if you come in here, that's a great picture.
He's like, oh my gosh,
Alright.
show me how to draw.
Do you see that angle that you just drew?
I know, that's spectacular to me. Mrs. A won't think that means a whole lot,
I was
but
saying like
sculpt
me that and I'll accept it.
we don't have time. What we were gonna do, I was gonna